All right, so hopefully everybody did a good job setting up their probability distribution functions. So I just wanted to review some things that we talked about with probability, because of course this is going to be important for what we're doing. All probabilities have to have a value between 0 and 1, so hopefully we have that ingrained in our head now. And if we add up all the probabilities that exist, then it's going to equal 1. And so that's going to be an important part of how we actually solve these example problems. All right, so let's look at our example here. So we've got supermarket customers, and the number of customers in line at a supermarket express checkout counter is a random variable with the following probability distribution. So there's a 10% chance that there won't be anybody in line, 25% chance that there will be one person in line, 30% chance that there will be two people in line, 20% chance that there will be three, 10% chance of four, and then a 5% chance of five people in line. And so we want to calculate some different probabilities. So in the first case, it's just saying what's the probability of two people being in line. So since it's just a single two, then that's just going to be just grabbing this off the chart and going from there. So P of 2 is just going to be 0.30, and that's it for that one. All right, so now we're going to start using some different language to try to capture more than just one value. So for B, we're trying to find the probability of no more than one person. So no more than one means in like symbols that we want either 0 or 1. So from a adding perspective, what we're trying to find is to find the probability that 0 people are in line or the probability that one person is in line. So we're going back to using our adding rule to do these kind. So in this case, 0 is 0.10, probability of 1 is 0.25. So it looks like we've got a 0.35 chance of having no more than one person in line, or a 35% chance. All right, so let's look at C. So let's find the probability that no one is in line. So that's just a fancy way of saying what's the probability of 0. And so we can see that that's 0.10. So find the probability of at least 3 people in line. So at least is the same thing as 3 or more. So at least 3 is the same thing as saying 3 or more. So from a probability equation standpoint, this is going to be the probability of 3 plus the probability of 4 plus the probability of 5. And so in this case, we can see the probability of 3 is 0.20, probability of 4, 0.10, and the probability of 5 is 0.05. And so when we add this together, we're going to get 0.35 for this. So that's going to be the trickiest part about this, is kind of thinking about the wording. We might use less than, we might use greater than, we might use, at least, at most, things like that. So trying to be familiar with those terms and knowing what numbers to include, what numbers not to include, and things like that. So if you get stuck on any of these or have any questions or about any of them, definitely let me know. So in the meantime, go ahead and work on practice 4, which is going to be using the probability distribution function that I made for you in practice 1. So we're just kind of like flip back to that page so we can use that probability distribution function. Practice 5 is using the practice 2 probability distribution function that you came up with, and practice 6 is using the practice 3 probability distribution function that you came up with. So work on those. Let me know if you have any questions, if you're stuck on anything, and then I'll see you in the next video. So good luck.